So now I think that we are recording. So let me close my stuff here. Oh, I'm not sharing the screen, so. But yeah. Anyway, that was the. I thought that would be the purpose today, to try to give you some assistance with the labs, and then also to do the early evaluation that I received. Well, we are only 5 people here now, so either we can do this evaluation now or on Monday, but I can bring up the screen for you anyway, so you can see what it's about. Let's see. Probably you know this already from other courses, and yeah, I'll just share the screen here. Okay, so things. So okay, yeah. So this one. Yeah. So this is the questions that we. Well, the administration says that we should use 15 minutes to have some input for these questions here, and then we should, or I should sign this, and the student representative should sign it, as I understand it, and then we need to hand it to the administration, or the one tier up in the hierarchy. It goes from the bottom and then all the way up to the top. But yes, so I didn't do this sort of dialogue before, so maybe if some of you are familiar with how we can do this in a better way, that if for example because it says there that this should be done in the class itself. Well, so yes, I'm not quite sure. What do you think? What's the best way? Course code is DAT520 distributed systems, and I think this is 10 points. Yeah, you can. Yeah, we could fill in the things right now. For example, I could I guess just send this document to you, and then you could write on your own machines, and then I can aggregate the answers into one big report, for example. So I could just, I hope the whole document. So let's see if I close it. I put the whole thing onto Discord now. And I will write, please answer and send me. So if yeah, I will just check the instructions one more time so I don't stay here. Yes, as the basis for the early dialogue is any answers in the students' survey and conversation with the students in a lecture. The course lecturer dedicates approximately 15 minutes of a lecture to ask what students think about the course. The students' suggestions for improvements are noted in a report. This must be signed by the course lecturer and at least one of the students. The report shall be handed to the study program leader. The study program leader hands all the reports to the head of the department. So, yes, if we use 15 minutes now just to write something, well, I guess it's up to you if you want to write, I cannot, well, if you don't have anything special that you want to write, then don't write, I guess. So, and then in 15 minutes I can collect the findings. Does that work for you? Or yeah, okay. Well, okay, let's then let's do that, and I will see you in 15 minutes. I'll just put up a timer for this. Let's do 15 minutes. Time. Yes. Right. Now there's a post that you can do on Google timer. Okay, I can get it to work if we do. Yeah, you can get like such a timer, but I never doesn't work for me. Anyway, that's not what we will discuss. So okay, yeah. So let's if you please could just answer the questions, and I think that you don't need to put your name if you don't want to. So. All right, then I will see you soon. Okay. So yes, I hope now we did that, and well, now 15 minutes passed. Don't know if you need more time or you're finished. Two of you already sent the report, and yeah, if anyone else feels that they want to send the report later on, we can do that also. Yeah, and I will. I guess I will aggregate, put them all answers and send to you, to Håkon, for verification. I think that's the way to go, unless you are at the campus. So if you're on campus, then we can just meet here. Else, I will just send it to you. All right. So good. Yes, the next thing that I want to do today is only regarding the labs and yeah, specifically lab 4. So is there any questions regarding lab 4? Yes, it would be much easier from, I think, to do it that way, that you ask some specific questions regarding the lab, and then I could maybe explain or give some tips. Because yeah, otherwise I don't know what parts that you find more difficult. Well, I guess it's the distributed implementation. And yes, I would like to, of course, help you and try to move you along the way. So the basic idea is that you will have this sort of architecture where you have one client that's pretty stupid, or he doesn't have any sophisticated algorithms. He has like a command line application where he can print out things to the console, or and also take in commands from the command line, and then he sends these commands through the network, and then these commands arrives at a different application called the Paxel server. And the Paxel server, this is where you will use your implementation of the Paxel algorithm and the failure needle detector. And you will have at least 3 of these Paxels servers, and they will communicate with each other by network also. And whenever they reach consensus, they will reply back to the client with the value. So it's my understanding that this is the part where most people are working right now. Yes, is there any questions that you have that would help you along the way. Regarding, it can be regarding pixels also, or the network layer. Yes, anything that you can think about. But yeah, if you don't have any questions, then I don't know what, if you want me to do something. If you want to look at any code or or if we were in a classroom, then I could see your facial expressions. But now I cannot see anything, so I don't know if you're following along or we or what we should do. But yeah, I had the plan today that since we postponed academia, then to use the time to help you along with the labs. So, or if you prefer to do it in private, it's also possible. Or I can yeah, I don't know. I thought that you would have some questions. Okay, for the client part, there's a set deadline function, but cannot find it. Okay. All right, let's see. Set deadline. In this one. Is this the thing that you meant, this set deadline? Because this one is, if I'm not mistaken, a method that's on the communication protocol. So if you were to Google, Golang TCP set deadline, then you would find that this is like a timeout type of thing that you. Well, it didn't actually say so much. Let's see if we have. Yeah, here we have a good description. So the set deadline sets the read and write deadlines associated with the connection. So this is like how long will you wait for either a read or a write operation. So if you for example say 10 seconds there, then this means that you will wait 10 seconds for a read or write operation. And for example, for a write, you're trying to write to someone, but if they don't read the value, you will time out after 10 seconds. So this set deadline, this is a function in the connection or the net package. And the net package, you can see here that it has different protocols. For example, it has the TCP connection, TCP listener, and UDP connection. So you see that these TCP connection and the UDP connection, they have almost the same methods. And for this lab, then you can, I think it mentions that you are free to use the network protocol that you prefer, but there's one caveat or some tip here, that if you decide to use TCP, which is like a stable connection, then you can instead of like doing the dial, like you see here, it has a dial. I think if we can, if you are not blind, dial function, and you, yeah, okay, let's see. You don't need to call this dial and then close the connection and then dial again, close again, dial again, close again for every message that you will find. But instead, you can, when you set up the connection with the TCP, you can just keep that connection in, for example, a map or array, and then you can reuse that connection for the whole demo, basically, or the whole application. Okay, so should the client connect to one or all of the servers? So I think that's well, this is that's up to you, but the most usual way to do it is that the client broadcasts the command to all of the nodes. So I don't know if it says explicitly here, but usually what we say is that the client can broadcast the command, and then those that are not the leader, they will discard the command, and then only the leader will process the command. But you are also free to, if you want to have a more sophisticated solution, yes, the client should attempt to reconnect to a different node for the following. Yes, but if you see the text, that if you send to only one, then in the cases that you have one of these type of operations, then you need to send to another one. But if you broadcasted the command, then you can basically say that your solution works in that way. Because I cannot remember that we have any specific requirements that the client must send to only one server, but this is the most common thing to do, that you will send to the leader. And in the cases where you don't send to the leader, then you can reply back with the address of the leader, and then the client can send to that leader, or that non-leader node could relay the command. So there's different levels of sophistication here, and this is for your own learning. So if you have time and the interest to do these things, then you're free to implement it in the way that you only send to one node, and then send and then yeah, handle the situations where you're sending to a non-leader node basically, or the situation where you have some kind of error with the read or write. Yes, but even if in the case where you send to all the nodes, then you could run into this type of issue. For example, if the client lost the network connection, so the client might be no, the problem might be on the client side. Yes. Yeah, so both ways work, but you remember that you need to really take care if you decide to go the route to send to all of them. Then there is I will show you in the code here in the I guess the proposer here that he get yeah this line here. So whenever he gets it's very small here. Okay. Whenever he gets a client value on the input channel, then there's a check that he is not the leader. So if you decide to go the route where you are sending to multiple nodes at the same time, then you need to think about these things here, that you need to ensure that only the leader will send a propose, and also need to consider the case that you have in this lab an eventual leader detector, which means that at any point in time, and the peers can have a different view of who is the leader. So this is, you don't have a group membership type of leader detector. You have only an eventual leader detector. So the view of who is the leader at the same time, it can be different. So this means that if two nodes think that they are the leader, then two of them will do these requests, and you will have yeah, you have to ensure that your system works in the cases where you have two values proposed at the same time. So this is what the Paxos algorithm should do, you know. But yes, the main thing is that you can demonstrate that it's working. I would say. All right. You said we have to use Docker for this lab, right? In that case, should we just try that from the beginning, or do you think it's easier to first test and make sure it works on the Python machines first? Well, I think that it's easier for yourself to just do it from the Docker containers from the start. Yes. And well, we have, I thought we put some Docker instructions somewhere, maybe in another document, but yes, the Python machines can be great also, but yeah, the most easy way is probably to just put the things into the Docker container and then run it from there, because then you have easy access to always run the things without having to first SSH to the Python machines, etc. So that's Even before you do the Docker things, then you can just like in your development phase, you will just like develop and test it on your local host first, so that you can. Well, if I would suggest to you how to implement this, then I would just have these two Paxos, these two roles here that we saw, the Paxos server and the Paxos client running on your local host on your laptop, and then only when you feel confident that the algorithm is working, the command line is working, the everything seems to be working, then you can do the next step to move these two things into Docker containers, so that you will have some kind of actual network communication. But you can do like most of the testing, and you can make everything work just on your local host, so that you will kind of have minimal development time, because if you can make the things work when both of these are running on your own machine, then it's a kind of small step to go to make sure that it's working when you have some kind of isolation between them. So like the network is working like as a channel to communicate between the two isolated environments there. So that's the idea. So I would do that I wouldn't start to put the things onto the Python machines or to put it into Docker containers, because you will spend a lot of time to do these things to like build the Docker containers or to move the files to Python machines, and you have like parts of the code that's obviously not finished, with missing functions or this and or that. So I would try to do the most of it on your local host, and only when you feel that you have completed most of it, then I would move it to one of those environments. But yes, so also I said that you for this labs we will accept if you show the network communication on virtual machines or Docker containers or Python machines, and also in last semester there was a group of students that like built a network between their own laptops. Okay, and then I said that's fine also, because you show that you have some kind of network communication between the laptops, so that's fine also. But the main idea is that you have to show to us that this application is working when there is some isolations between the servers and the clients, and you cannot get this isolation in a reasonable way on your local host. Yes. So I hope that was clear. And of course, if you're running Windows, then it can be maybe more difficult to test this on localhost, but I'm not quite sure. I didn't try to do this on a Windows environment. Yes. So any further questions? this distributed implementation that you do here, you will extend this in labs 5, where we will have that you should use this this application as a bank. So it will be like you have some kind of real world usage that this 3 Paxos servers will represent the bank, and then the client can deposit and withdraw money from their accounts, and the system will work even if one of the bank servers goes offline, etc. So that's what you will do in lab 5, and from this it's obvious to realize why there must be a consensus, and you cannot have anyone proposing different values, etc. Because if you allow that, then it would be easy to screw up your funds in the bank. That if you somehow could withdraw more than was in your account or something. But you will see more on that on the lab 5. Yeah. Any other questions? Because if not, then I will let you continue with this. And yes, if you need assistance, you can reach out to me or the TAs. So the plan was that the deadline on this would be on Monday, and I really hope that most of you can finish this by Monday so that we can progress to lab 5 and then to lab 6. I want that you will finish this, and especially for your report, this is very relevant. That you will have a good understanding of how this Paxos works, and yeah, I think that if you want to understand how it works, then you need to implement this. But it's kind of difficult. Yeah. You're all silent. So it can be a good and a bad thing. But okay. So we can end here for now, since there was no more questions, and I will try to be available for the lab tomorrow, or you can try ask some questions in the Discord channel if there's something that you are stuck on. Yes, and thank you for the answers for the early dialogue part, and I will send this to you, Håkon. I think so. All right. Then see you all. Bye-bye.